Hello everyone, it's November 25th. Let's do this. Oh, I think I hurt myself. Oh, something is hurting. Oh no. I'm in no mind to do this. It's already 10:20, 37. I need to eat. Alright, so we read through it and we try to see if we have a solution. If not, okay, 10 minutes. 10 to 15 minutes we're gonna spend. Zero indexed matrix integer k. You're currently at position 0, 0. You want to reach position bottom right. Moving only down or right. Return the number of paths where the sum of the elements on the path is divisible by k. Sum of the elements is divisible by k. Since the answer will be large, we'll return a modulo. Sum of the path divisible by k. Okay, so first thing we can see is we'll modulo everything, but hold on, it's only go to 100, so that's not very big. But we can still do that. We can modulo k for every single one, and then okay, yeah. And then we want the sum to be divisible by k. What we can do is, starting from a position, we can say how many paths, because we can only go down or right, so that makes things a little easier. So at a certain position, we say how many paths there are to get. So essentially, here's what we propose. Right, we propose how many starting from here can get to can be divisible, right? So starting from here is 0 because it's 2 is not divisible. Okay, and then we say to get here we can go this or this, or go here. 5 to here is 7, so that's also 0. This is 1 because 7 to 2 is 1, right? And then from here we can go this down, so that's we need a prefix sum. We need a sum as well, and we need a count. Also a count. Okay, so it's 2, 0. Right, this will be 7 and 0, and this will be 11 and 0. That's nothing, right? So here is 9 and 1, and this we go here is going to be 7 and 0, but if we go down it's going to be 9 and 1. I have one path, right? And here is going to be 9 and 1. So now we go here. We basically has one path go here, 13 and 0. One path go down, but after we go down, we have two different options. So it's 2, so we actually have 9 and 1. And we have 11 and 1, 9 and 0, and 11 and 1. All right, 11 and 1. And over here is a 3. So it's going to be 10, 0. So 12 and a 1. And 12 and a 1. So we have basically 2 of them. Okay, 5. So we have 18 and 1. 14 and 0. Oh, 16 and 0. It's here things get complicated, because you have to add all those up. So like that. And at 5 we have 15 and 1. Huh. So this should be all modulo instead of doing this, so we can guarantee that each cell at most is k, right? At most is k, is 50, right? At most each cell has k different states. So we can do a list of a list, right? So here is just, 2, we have 1, and this is going to be 7 minus mod 3 is going to be 1. Oh, it's a 0, right? 1, and then this is 5, so it's 2. I have 0. And then we actually go like this, 2, and then this will be 0, and then we have a 1. This will be 0, and then we have a 1. Right? Basically, we say if we go this way, we have a path. And this is that, and then this we look at both, so that's a 0. So basically we have a 1, 0, and then 0 we have a 1. And then we go here, this is a 3, so 4, so we have a 1, it's a 0, and then it's a 0, it's a 1, a 0 is actually 2. Now we go here, that's a 2, so we have 2, 4, that's a 1, it's a 0, right? 1 has a 0, 2, 3, so that's a 0, we have a 1, and then 2, we have a 1. So coming here, it's a 5, 5 plus 1, so we have 0 is a 1, 5 is a 2 is a 1, 5 is 7, 1 is a 1, 5, 6, that's so 0 is going to be a 2, 5, 2, 2 is going to be 3. So the answer is 2. Well, we can give the shot. Maybe DP will work. Not DP, yeah, maybe DP will work, going from bottom right to top left, keeping track of the number of paths for paths whose sum whose sum mod k, right? The number of paths with a specific remainder after their sum mod k. We'll act on the grid directly. Size. And then we'll say int mod is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then we'll create one besides dd vector of vector of vector. Yeah, so it's a vector of vector, it's a vector of vector of vector, say dp, and top level is m, and the middle level is n, inner level is gonna be k. Okay. Okay. Huh? Okay. So now what we're gonna do is we'll fill in the last row, because last row, so last row in the right column, because those don't have, oh, we can do an if check. So we'll fill in the last one. Okay, so it's a grid. Now dp m minus 1 n minus 1 and grid m minus 1 n minus 1 mod k. Actually, maybe we can just say for int I n minus 1 I minus minus okay, and then we say the next one, right? So we can say look down. We need to get a value down. We need to get the value down. If you wonder, Maybe you should just add one more. Right, then you can look down, go through all of them, and then those are remainders. Yeah. So look down is gonna be dp ij. This is going to be grid ij plus r, which is the remainder down, and the whole thing we're gonna have to mod k, right? That's the new remainder. Current r. Plus I plus 1 j, because we'll go down, we look at r, right? Because we'll look at r, this is the remainder, previous remainder is this, and now I add this, so we get a new remainder. So plus this mod, right? Let's look down, we go through all of them. So current r, when do we add 1? If current r is 0, because if current r is not 0, but if current r is 0, then like this value plus this value becomes 0, then we need to update. So yeah, like this 1, where does this 1 come from? Because this becomes 0, so we add a 1, right? But how about this one? Why doesn't this, because this is like one path, this is the first path, and yeah, why doesn't this one? Because the first one that has, we can just say from this, right, we have one path, but the following, that's not a second path. The number of paths, right? So the number of paths, this is the number of paths when you go down, right? There's a number of paths that can lead to 1, and then when you get to 0, right? So if, wait, hold on. So basically, if we have a path and you add that path, basically what we want is how many paths there are for each remainder, right? That's what we want. How many paths there are for each remainder. So therefore, because we will go for all of them, right? That's actually not true, right? What I think we need to redo this whole thing. What we want to find is the number of paths for all the remainders. Right? We're doing all the remainders. So if we're doing all the remainders, each one is going to have 0, 1, 2, right? So this basically is 0 because it doesn't work. This is also 0, but this is going to be 1, right? And then if you go here, 0, 1, 2. So what we do, this is 7. So we'll add every single one with 7. Add this. 7 add this is what? A 7. This remainder is 1, right? So basically, from here we have 1 path. No, that's not right. That's not right. We have 0 path to get to this. So basically we're saying from here, if it's a 0, then that's a 0, right? So basically 1 is a 0 because you start from here and then you go here. If you check the 0, which has a 0, which means we go through this. If it's a 0, then whatever this is, we add this is going to be 0, right? So 7, that's a 0. 7 plus 1, 8. 8 remainder is 2. So 2 is going to be 0. And then 7 plus 2 is 9, right? 9 because it's a 1, so we inherit the 1. So in that case, this has to change, right? So we have the current R, that's fine. Then what we need to do is we say if dpi plus 1, right, dpi plus 1, j and r, j and r, if it's equal to 0, right, that basically means we don't have anything for that. Then we say dpi j current r is also going to be 0 because there's no path, right? There's no path. Actually, I think we and if there is a path, right? If there is a path, then it's going to be the current plus. So this is a correct then, right? This is a correct. This is the current. Will be whatever the current is plus whatever this one has, right? Whatever this one has. And then if this is a 0, then we hold a second. This is 0. This is always going to be 0 to start with, right? It's always going to be 0. But eventually we'll like hit 1 path. No, that's I think it should be fine. So just look down. Actually, grid. So this is look to the right. And then we'll go through everything and then we will return dp 0, 0 and 0. Okay, let's give this a little run. Let's see if it works. It does not work. I think it's because we never get this. Okay, we never get this. Why do we not get this? Because we need to have so what I think, because right now we have extra, okay? We have extra. So I think this extra matters. So how does this one come into being? Now this one come into being because this is a special. You have one path to this, which means because this look to the right, right? And then this is a grid ij is 2, right? So 2 plus this. So the current value, and then plus the remainder of those, that will be 0, 1, 2. So if the 0, so then when r is equal to 0, so if here 0 is 1, 1 is 0, and 2 is 0. Okay, here is the same thing. Oh, we probably shouldn't do the same thing. We should just do one of them. I think these should all be 0, right? And then when we go for 0, because it's a 2, 2 plus 0 is 2. So the current r is 2. Or plus equal to, this is 0, so we get a 1. But then when you go 2 plus 1, 3, so that's a 0, that's a 0, and this is all 0. So what we're saying is maybe we say dp, okay, m, actually not m, I think it's m minus 1, n 0 equal to 1. Just setup. Oh, but then this, no, this is the only one who can capture this, right? So set up a seed value. Looks fine. You want to try this? Okay, we can try this. OMNK. Let's see if it works. Oh, it freaking works. It freaking works. Huh. It's not bad, huh? I guess you can do that, but at this point, why bother? Okay, wow, it's actually not that hard. It kind of, I mean, this is a signal of DP, and it's actually quite simple because it can only do right or down. You don't have to go 4 directions. And divisible means something like you can do modulo, and then we just do all the modulo, and the rest is just to configure it in the right way, right? And also the hint is k is only 50, n by n is this, so this multiplied by this is good. So yeah, that's pretty much it. All right, that'll be it. I'll see you guys tomorrow. Adios.